In this video, we're going to show you how to connect an evaluation board to the new PowerNavigator GUI. For this example, we're using the ZO8800 dual output demo board, and we've got it connected right now. So it's set up with a 12-volt input supply. On the bottom left here, we have the dongle connected that just connects in through a cable to the USB port of the PC. That way, the PowerNavigator GUI can send signals across USB, which converts it with a dongle to PMBus commands. The first step we do is start up PowerNavigator software. And right away, the device will go out and scan for any demo boards that are present on the system. And as you can see, it's detected the ZO8800 at address 31. So we click on to monitor hardware, and we start PowerNavigator. This will automatically launch in to the part view, so you can see the architecture. It's detecting two separate outputs. The top one here is configured at 1.2 volts, and the second output is set to 1 volt. If we go into the monitor view and holding down the control key, selecting both parts so we can monitor them both simultaneously, we can see exactly the system that's running. So walking through this, we can see that there's a 12 volts applied, or 11.89 volts. We have two devices set up, one at 1 volt and the other at 1.2. And they're both basically pulling no load current at the moment. Now that we have the demo board up and running and connected to the GUI, we can start making changes within PowerNavigator to control the operation of the device. So let's start off with how the monitoring screen works. With this demo board, we have two switches for enable pins on channel 0 and channel 1. So we can control these individually. So right now we've just turned off channel 0. And right away within the GUI, you can see how the channel is reporting 0 output voltage, and the power good signal has now deasserted. The device, if we look at the fault screen, will appropriately read that the power good signal is off, and that's because the device itself has been turned off. We turn it back on, you see the fault status goes away because the device is now active and in a known good state. We can also do the same thing by sending a PMBus command. Right now, the device is configured to only receive enable commands through a hardware. We can simply select this on the top of the GUI to say PMBus enable signal only. And now the enable pin becomes active at the top of the GUI, and by toggling this, we can turn the device off or back on. We can now make other changes to the device, such as changing the output voltage on the fly. And this is possible through several different methods. We can go back to the power tree and change the output voltage. At the top of the GUI, you can see the output voltage is set point at 1.2 or 1 volt is displayed, or we can go in through the dialog boxes on the output voltage readout. Let's just take the method at the very top here. Instead of 1.2 volts, change this to 1.1. And you can see right away the device has responded and adjusted the output voltage down. One of the other ways of changing the output voltage or any of the other parameters is to use the command line tool. So we're going to go through the same procedure we showed in one of the earlier videos in accessing the command line tool and changing a few of the parameters. And now you can see how it works with an actual demo board connected. With the command line tool open, we can see that it's set up right now to sit there and control and configure the ZO8800 on channel 0. And that's the 1 volt output. A quick, easy way of confirming that is just to go into the command and type in the vout command. If I click on this, you'll see that it's displaying the 1 volt output is currently being read from the device. If you want to read back the latest data, it does automatically populate it, but you also have the read button here that you can click to request a new command to come back and read the status from the actual device. So let's go ahead and change the output voltage using the command line tool. So we've entered the vout command in, and you can see it's reading right now that it's set to 1 volt. And we can always verify this by clicking the read command. So it's requesting the latest information from the device, and once again, it's still saying it's at 1 volt. Now if I put a new value in, such as 0.95, and I hit enter, you'll see two things. The first is a lack of change on the monitoring screen. It's still reading a 1 volt output. And that's because on the command line tool, you can see the send button is now highlighted yellow. The GUI has accepted the command of 0.95 volts, but it hasn't sent it to the demo board. As soon as we click the send button, the yellow highlight goes away, and it sends over the command as recorded at the very bottom of the screen, And you can see on the monitoring view, it has updated and the output voltage has now changed from 1 volt to 0.95 volts. After you've made all the changes in the GUI, configuring the different parameters and settings of the demo board, don't forget to issue a store user all command. This can be done through the command tool, just typing in store user all and then hit the send command. The reason why is this will then save all those different settings you have from the volatile memory of the device into its flash memory. That way, if you power off and power back on again, all those savings are now saved. Conversely, you can also save off this as a config file, and you can load it up and store it into any other device you wish. We've just covered a small piece of what can be accomplished using the new PowerNavigator GUI with evaluation boards. For more information and to try for yourself, please order your own evaluation board and get your own PowerNavigator software from Intersil.com.